In this prototype, I want to try and solve a very simple game, the game of Jumble. And as you know from having played this in the newspaper before, the game of Jumble is you're given a bunch of letters and they're in some random order, and you have to figure out what's the actual word corresponding to the letters that you have. You have to use every single letter, and you have to rearrange them. And you might think, well, this is actually pretty straightforward, but how do I discover the deliberate process that leads me to that answer if I don't already know the answer ahead of time, if I don't have a cheat sheet off on the screen to the side that will tell me what the answer is? And so, why don't we get started with this very simple prototype, and we will take a look together. Now, of course, there is one small thing that I'll need to set up before I look at this. I need some set of words that I'm going to look at, and so I have a file that is provided to me that has all of the words that I'm going to choose from as part of my game. And if I take a look at this, I can say for each line in this thing, print out each line. And I can just take a look at the first one and just see what this looks like. And you can see this is a file. The very first line is A. If I take a look at, say, the first 10 lines by enumerating this, and this is one of these things, to know to reach for enumerate rather than to write the loop by saying line number equals 0, line number plus 1. This is experience. But it isn't anything that, is beyond what you might be able to very easily pick up by doing these kind of things over and over. And so here, if I say if line number is greater than 10, then we break. And so I can look at the first couple of lines of the file, and I can see from this, okay, it's one line per word. And this is my list of words, and you can see some of these words are interesting, some of them aren't. Probably the daily game of Jumble is going to allow me to select the word aardvarks, but not aardvarks with a possessive S, because I don't think that kind of makes any sense here. And clearly, things like contractions and words with possessive things like that aren't really included. And similarly, I suspect that the daily game of Jumble is not going to include acronyms like AAA. It's probably going to limit itself to words that are of a particular form, probably words that don't have any punctuation in them, and words which, as a very simple, as an extreme simplification here, maybe only start with lowercase letters so they're not proper nouns. And so the very first thing that I might want to do is I might want to prepare my words. Why might I choose to do that first? Well, you can think there's really two parts to this: preparing the data and then writing the code that solves this problem. And does it matter which I start with first? Well, oftentimes what I find is that the development process, the process of developing code, is about hitting a particular milestone or hitting a particular deadline. And so I oftentimes choose things which I already know how to do because I know I have to do them anyway. I can't solve this problem without solving both of those parts. They're not really dependent on each other because, for example, if I chose to solve the actual, how do I write the algorithm to find the word, I could just hard code the data. I could say words is an empty set, and I could say, or this is my word list maybe, is an empty set, and I might say, find Jumble given the letters and given the word list, like that. And you can see I don't really need to do the data loading. I could do these separately. And so there really isn't a dependency here. I'll often choose to do the one that I'm able to do because I know it's better to just lock something in that needs to be done no matter what. So I'll start with just the word list. Here, one of the things that I want to show you is there is a deliberate process involved in how we choose where to get started. Clearly, if there are dependencies, we have to handle the dependent tasks before we can handle the tasks that are dependent on them. If there are not, it's oftentimes a worthwhile effort to start with one or two things that you know how to do just to lock it in so that if you have stakeholders, you can show progress, and then to look at things which you're not sure how to do to make sure that you don't burn through all of your time doing tasks that you're already aware of, but instead you're sussing out, oh, hold on a second, this is actually really difficult. And so I'm going to do this in two portions. I won't do each of these parts to completion. So for example, I might do something like this. And note, I'm not even going to write a function for this. I'm just going to prototype the core of this portion. Here, I know each line is actually a word, so maybe I might say word equals line, and I might strip off any white space from this, and I might print out the word. I might filter this down, and I might say, okay, if the word it doesn't start with an uppercase letter, I might do something, or if the word, the 0th item of this is upper, I might skip it. And here's where one of the intuitions that I might have, but is a very deliberate intuition, might help out. Anytime I'm doing successive filtering of some kind of data, probably, if I do a bunch of filtering steps in a row in some for loop, it's going to be really difficult for somebody to assess. Oh, hold on a second. I know what the input was because I can see it here. I can see what the output is because I can print it out later. And what I'm not sure is, what is the process that got you from the input to the output? And so here, an intuition may be that what's worthwhile in this code is to make it very clear how you got from the input to the output. And one way to do that is to break it down into discrete steps. And if I want to break this down into discrete steps, I might think, what Python feature allows me to do that? Well, for a successive series of filtering and transformations, things like comprehension syntax or generator expressions allow me to do this. And so I already have an intuition for what I'm going to do next. I know that I have this goal, and I know that I have this feature that allows me to accomplish this goal. And so what I'll do is I'll say, you know what? Here, I will start with the raw words. Now, deleting a bunch of code and starting over from scratch is probably never a good sign because I had progress before. Why would I delete that? But what you can see is when we show you this kind of lie of live coding or lie of what you're able to solve, oftentimes the truth behind it is, well, you know, there were incremental steps. I did write it one way and then I chose to rewrite it. But I'm just skipping ahead the steps because you don't always need to see it when I'm doing long division every time I borrow a something or carry a something. And so here, there's a little bit of a lie, but there is a fundamental truth that at some point in time, I went through the process of writing it one way, and then I discovered, oh, hold on a second. Subsequent filterings and transformations work very nicely with comprehension syntax. They're very readable, and so I'll just skip ahead to that. And so here, I might do something like line.strip for line in F. And here are my raw words. And then I might say, you know, my word list is equal to, you know, each word for word in raw words. And one thing that you can often see that we do is we use very short variable names because if we're doing live coding, you know, we want to make sure that we don't mess up. We want to make sure that we don't accidentally write the wrong thing. And so it helps us quite a bit to make this very clear. Now here you can see, okay, you know what? I actually probably wanted to do a filtering of this. So I might use a little bit of flourish, you know, use this generalized unpacking syntax on these items. But now encode each one of my filtering steps. So I'm going to do this if the word's 0th element is not uppercase. Actually, I'll do it only if it's lowercase because I guess there could be numbers in here. And so that gives me everything that doesn't include those proper nouns. And that's a very simple filter, but you can think this is room for, this is my remove proper nouns. If there's a proper noun that happens to have a lowercase first letter, well, I could independently change this line to fix that up. And then here, maybe I might remove anything with apostrophes or punctuation. So I might say word for word in raw words. If, and then I could write this in line, or I could write this with a separate function, but I might do something like this. If all C dot is alpha for C in W. So if everything is alphabetical. And so here, I should remove all of those. And so you can see I didn't even put this into a function. This is interesting. You can see it didn't quite work. And it didn't quite work because I had a typo here where I should have just used the same variable name over and over, and there we go. And so here you can see I didn't put this into a function. I didn't do anything fancy. I kind of proved that this was possible. Next, we'll assume that we have a word list, and we'll work on solving the jumble. So assuming that we have a word list, how do we actually solve the jumble? Well, I could start with a test-driven development process, and I think that's a very formalized way to do this. Or I can start with a very simplified version of that. Basically, hard code some data and then iterate until I get that working, and then maybe do a test-driven development process if I am willing to take into account some of the mechanics and some of the setup and all of that that's necessary for this. I'll actually show you both approaches, and you can decide based off of the time that you have and based off of the formality or the criticality or the worry that you have that you might get this wrong, which of these two approaches you might want to take. Here's the simplified version of this. I have my letters, and so let's pick a word that I kind of know the answer for, H-T-O-N-Y-P. If you know what this word is, put it in the chat, or if you're watching on video, take a moment, pause, and try and unscramble this in your head. It's always good to start with the case that you can solve manually by yourself, just to make sure you understand the problem. Here is my answer using find jumble. And the moment I do this, I might discover something. I wrote this wrong. Find jumble doesn't give me an answer. Doesn't it give me answers? Because when I look at this, I say, well, hold on a second. There's actually two words. There could be Python, or there could be Hontip. I don't know if that's a word. Maybe something like phyton. I think phyton is a word. So could be multiple answers. And so what I might already know that I need to do is I might need to say, oh, you know what? This should be answers. And maybe if I'm returning multiple answers, I might choose to make this some kind of generator. Because oftentimes when I have some function that can return multiple possibilities, there's a distinction between the question of, do you just want anything, or do you want all of the possibilities? And because the generator gives us the ability to control externally how long a computation runs for, it may be beneficial for us to start off with some sort of generator that allows us to know, oh, hold on a second. Some people only want just one answer, whatever the first thing that comes up is, and other people want all of the possible answers. Maybe they want all the possible unique answers, and other people want all of the, if this word list happen to have duplicates in it, all the duplicated answers. That maybe is a little bit less likely, but you can think the one or many is pretty common. So I already know what this is going to look like. It's going to look like this. And of course, just to allow myself to iterate, I'll print out my input and my output. And it's always great when your variable names line up, isn't it? There we go. So here we have our input and output. Well, clearly we have to check every single word in this word list for this very simple approach. So we're going to check every single word, and we're going to see if it matches up to the letters that we have. Now, here's where it gets a little tricky. And we might say, how do we know if this word happens to match against this particular set of letters? Well, one thing that I might do is I might, as part of my iteration process, not even do that check, just kind of do one thing, yield one value and see if the rest of this works. And you can see one problem that I have is because my word list was empty, well, this thing didn't give me answers. So let me put in Apple, Python, and Phyton. So here we go. And you can see, okay, that seems to work. It didn't really check anything. It just gave me the first thing that was there. And obviously, if I add another word, it just happens to be the case that it gave me a right answer. But if I add another word, there's a very good chance that, it might eventually just give me a wrong word. You can see here, it just depends on what the sorting of this word list is. Do I need to process these in sorted order? Not really, because you can think the choices are more or less equivalent. This is one part of sussing out the problem that I might have. Now, I want to pause for a second before I continue, and I want to show you the other approach that I might take. If I wanted a fully test-driven development approach, then what I might think is I might say something like test jumble. And I might hard code these, and I might say assert, answers, or assert one answer that I anticipate to have is in these answers. And I might say, if I have PyTest installed, let's see. If I have PyTest installed, then I might be able to even say, from PyTest import main, and we'll even see if we can run our PyTest on this particular file. Now, this is the so-called test-driven development approach. The reason why I don't know, if I don't have PyTest installed, then I can't. But the reason why I don't know that it's that particularly valuable is this is a fairly poor test. This is an oracular test. This is a test where some invisible oracle, namely me hard-coding the expected value and the actual value, are able to answer what a correct response is. And I really don't think this is, beyond a smoke test, a very good test. It shows that we've done something horribly wrong if it fails, but it only tests one input against one possible output, and it had to require a human being to intervene to say, oh, this is the pairing of the inputs and the outputs that we accept. And so as a test, it isn't particularly scientific. It's really just a, hey, did I really mess things up, or is this working? But not, oh, did I forget some tiny little corner case? Because this won't be able to catch any corner cases. This is why I might avoid the test-driven development approach, because whereas test-driven development is good for the long-term maintenance of this if I write something a little bit more sophisticated, like a property test using tools like Hypothesis, here I really don't see that it has a huge advantage over just starting with something as simple as this. It really isn't giving me that much more. The smoke test is useful to codify later or to formalize later, but here I think this is sufficient. Now, let's think about the core of this problem. I need to match up the letters against the word. So I know that, for example, a very simple but probably fairly inefficient way I can do this is I can count things. And one of the things that I know as part of my deliberate process is it is often in these problems a choice of data type that determines whether this operation is done effectively, efficiently, and readably. And if you think about the data type that I need, I can see that it's not just pulling out of the air, oh, counter because I've done this before, or pulling out of the air counter because, I have a little bit of insight into the answer. It's more of, well, if I see one P, one Y, one N, one O, one T, and one H, I know the respondent word has to have exactly those characteristics. And if I need to count things, well, I can use a counter or a pandas series. And so here I might do something like if this is equal to a counter on our letters, then we yield the word. And we can see, did this work? Great. Now that we know that this works, we can actually plug it into our problem with our real word list. And we can conclude our prototype because I think we have all the pieces that we need. And here you can see, let's do that. And here you can see with our real word list, it gives us just the word Python. I guess our dictionary doesn't have the word phyton. But if we try something else here, like, let me think of a word that has two, maybe, ooh, that's always tricky to think of a word that can be spelled in two different ways. Maybe horse. I wonder if horse has another possibility. Sure. Or I have no idea what that last word is. Or banana. I wonder if banana has another possibility. Oh, it's only banana. What about orange? If you jumble orange, there's actually also an anagram finder if you think about it. But there we go. And let's, Gorane turns into orange. But there we go. We have a prototype. And you can see the deliberate process in place. Now, why don't we leave this prototype here? You can see that there's a lot more that we can do. We can make this a load word list. We can, even maybe make this a method on a data type that is created. So as we go, we could say, oh, you know what? This should be a from data classes import data class. But I don't think that this is where we would start with this, to start with a class word list, because I think that that is really very presumptuous. And a class method here telling us that we're going to load this from word list or from file like this. I really don't think that this is a great way to get started because this is very presumptuous for what we want the end user code to look like, the API to look like. And really, that should be something that we prototype separately. So I'd actually prototype what that looks like separately from either the data loading or the solution.